Okay, so we've talked about acceleration. We know that it is the change in velocity over some time interval. We worked with graphs for velocity, and kind of reviewing, looking back, we know that the slope of a position time graph gives us what? Go ahead, I see you making the velocity. Yeah, velocity. Well, what if we talk about, so now that we know what velocity is, if we have velocity graphed against time, if we have velocity graphed against time, what would our slope units be? Oh, looky there. Our slope units would be meters per second squared, because at this point our delta y over delta x is our change in velocity over our change in time. That looks familiar. I feel like I've seen that equation somewhere recently. So weird. So the slope of a velocity time graph gives us acceleration, which some of you probably had already figured out, because again, you're clever critters. So let's do some of the same hijinks with acceleration on a graphical perspective that we did with velocity on a graphical perspective. And let's be very careful. Remember how I said, number one, don't say deceleration. Number two, be real careful with positive and negative acceleration. So, okay, let's look at that section of the line. Number one, is the velocity constant here? Velocity? No. Velocity's my, yeah, sorry. That was an intentional trick. That was evil of me. I apologize. No, I don't. So velocity is not constant. Is the acceleration constant in segment A? How can you tell? Straight lines. Slope is constant, therefore the acceleration is constant. Is the Is the velocity constant in segment B? Yes. Yes. Is the acceleration constant? Constantly zero. That sounded funnier in my head. So it's a constant zero acceleration. This is you with the cruise control on the highway. Is the velocity constant in section C? No. No. Is the acceleration constant? No. No. Okay, so good. We get constant and not constant. Excellent. In section A, is the velocity positive? Yes. Is the acceleration positive? Yes. In section B, is the velocity positive? Yes. Because velocity is our y value here. The magnitude of the y value, see, magnitude, tells us if the velocity is positive or not. Is the acceleration positive? Well, it's zero. I need to go consult my math friend. Zero is neither negative nor positive. When I hit something that I feel is like a little technical math thing, I go talk to Mr. Andres, and he always makes it crystal clear for me. So I'm pretty sure we just consider that zero is neither negative nor positive. It is just zero. It's its own thing. In part C, we said the acceleration is not constant. But let me ask you this. In the portions of line C where the acceleration is non-zero, is it positive or negative? Positive. Yeah, it's like positive acceleration, zero acceleration, positive, zero. They're speeding up, but they're jackrabbiting on the gas. That's how my mom drives. Okay, now let's take this same object and do this. So, in portion D of this line, is velocity constant? No, it's changing. Is acceleration constant? As best I can draw it. Yes. Sorry. It's a little wiggly, but yeah, it's supposed to represent, well, I guess from there we could say it's pretty constant acceleration. Is the acceleration positive or negative? Negative, because the slope of the line is negative, and we know that slope of a velocity timeline gives us acceleration. This is easy. Why are you making such a big deal about this, Moser? Those of you who've had me for chemistry know, well, they don't say that in chemistry. In physics, they always say every time that I say something is easy, that means we're about to complicate it. Foreshadowing. Okay, here's the question I want to ask you about the object itself. We said that the acceleration here is negative. Is the object speeding up or slowing down? You can talk to your table. What does it mean for an object? You can talk to another table. What does it mean for an object to slow down?
Decelerate.
No. Smarty pants. How many of you say it's slowing down? Yes? How many of you say it's speeding up? How many of you are too chicken to commit to a position? What is happening to the magnitude of the... Okay, so describe for me, you're in your car, you're on Route 11, you're going 105 kilometers an hour, and you hit the brakes. What happens to the instantaneous velocity which is shown on your odometer? Does it shoot up to 115? Does it drop to 100 and to 95 and to 85? The magnitude of your instantaneous velocity decreases. The magnitude of your velocity decreases. The numbers get smaller. So for this object, here it's got an instantaneous velocity. At this point, its velocity is probably something on this badly drawn graph of like 8 meters per second. And here it's 2 meters per second. And what's its velocity at this point? 0 meters per second. The magnitude of its velocity is decreasing, therefore the object is doing what? Slowing down. It is slowing down. So when the magnitude of the velocity decreases, an object is slowing down. In this portion of the graph, in part A, what's happening to the magnitude of the... We said the acceleration is positive, the velocity is positive. What's happening to the object? Is it speeding up or slowing down? Speeding up. Oh, okay, I get this. This is easy. Positive acceleration means you're speeding up, and negative acceleration means you're slowing down. Okay, so here I have a slightly different graph. I have origin for velocity. 1, 2, 3, 4, 5. Yeah. Here, we'll do that. And then, -2, -4, -6, -8. Can you have a negative velocity? Sure. If you are moving in a negative direction, if we're calling east positive and you're driving west, you have a negative velocity. You may be going negative 115 kilometers per hour, but we consider it a negative velocity because your displacement is negative. Okay, good. You all understand that. Excellent. Smart critters, like I said. So we start off at origin, and we drive this way, and we drive this way. And in portion A, is our velocity positive? Yes. Is our acceleration positive? Yes. In portion B, is our velocity positive? Yes. Our velocity is still positive. How do we know our velocity is positive? Location of the line. We can actually look at the y value for any point on this line, and because the y-axis is our velocity, if our y value is a positive number, that means in this case, you have a positive velocity. Okay. In portion B of the line, is the acceleration positive or negative? Negative. It's got a negative slope. What's happening to the object? Slowing down. Now, we take our dog on a skateboard, I like that, and we go here. Now, in portion C of this line, I'm going to have you talk to one another at your tables. Don't yell it out. Is our velocity positive or negative? Tell one another. Okay. No real ramp jumping. That doesn't happen until chapter 3. So in part C, it seems that there is tremendous agreement that velocity is negative, because we look at the y value for the points on that section of line, and we know that those are negative numbers. Now, is the acceleration positive or negative? Slope of line. Slope of line. Look at the line, look at the line, look at the line. Negative. It's a negative slope. Is the object speeding up or slowing down? Talk to one another. And how many of those tables are in agreement that this object is speeding up? Ooh. How many of you think it's slowing down? You guys are good. How do you know it's speeding up? It is getting further from zero. The magnitude of the velocity is increasing. The magnitude of the velocity is increasing. The actual distance on that y-axis number line from zero, the numbers are getting bigger. To put it in the terms that, are simplest. The numbers are getting larger. The magnitude of the velocity is increasing. It may be in a negative direction, but we don't care. That thing is speeding up. Now, let's look at portion D, and this should be easy because you guys nailed portion C. Is the velocity positive or negative? Negative. Is the acceleration positive or negative? Positive. Is the object speeding up or slowing down? It is slowing down. It is coming to a halt. The dog on the skateboard is going to stop. So you can have a positive acceleration with an object that's slowing down? What is real and true in this world? Math, that's what. So yeah, be very careful about linking positive and negative acceleration to the actual action of the object. You can have, it depends on the sign of the velocity. So this is what I wanted to talk about. That covers it. Guess what you're going to see on your recall quiz on Monday? A graph that shows velocity that is both positive and negative with pain in the tuchus questions about whether the acceleration is positive or negative and whether the object is speeding up or slowing down. But I think you can all do that. So now you've got time to make my dreams come true and give me a pile of A and Bs to grade on my couch on Saturday morning while drinking coffee. If you're already done with that, you can think great thoughts and review whatever you need to.